Good afternoon. I hope you enjoyed your lunch and all the sunshine. My name's Scott Menter. I'm the Chief Strategy Officer at BPLogix. This is my boss, Joby O'Brien, who's the guy who actually knows stuff. The 18th century British Empire, you knew I was going to start there, sought to rule its vast kingdom from the throne of King George III, or as we in this room might put it, their widely distributed assets were all governed by a single shared resource. And that worked okay for a while. Then it started to not work okay. One day George Washington came along and he and his buddies took control. Other nations followed suit. The lesson here, the arc of history is long, but it bends towards distributed control of resources. Always remember. In case you haven't figured out where I'm going with this, it's this. IT is King George III. They're hoarding all the development talent. Business units are the long-neglected colonies. We all know, or I could read that one again. BPM broke the model. We all know that this arrangement couldn't last forever, and it didn't. BPM broke the model, handing power to build custom solutions to analysts and other clever business users. While IT retains governance control, each P&L manager is pretty much free to invest at their discretion in digital solutions they deem most suitable, right? So that gives them the control they want. Coding, however, is not the only shared specialized resource in a company. Of the others, arguably the most important today is the ability to develop machine learning models and to apply them to actual business cases. That requires some arcane knowledge. And if ML becomes half as ubiquitous as the pundits would have it, data scientists may well be the new programmers in the sense that they're shared resources, they're hard to find, hard to retain, and expensive. And business units will again be competing for the results. So what are we going to do? Well, think about this. Democratization of development wasn't about turning everybody into coders. It was about giving normal people, or more normal people, a level of abstraction that they could deal with. You have to keep in mind, though, machine learning is really hard. This is an actual slide from my son's ML class. So if we're going to democratize it, it isn't going to happen by turning people into mathematicians who can understand this, right? We're going to have to give them abstractions that they understand. So we attack that problem in two ways. You can swap machine language into process timelines built-in predictive model, so you could do that instead, and access native process director, native data and metadata as input to any ML algorithm. Adding that extensibility to our existing process timeline predictive model is a great example of layering in abstraction. A number of process director behaviors already exploit predictions. You just plug yours in. You just plug the way you want to do it in. So for example, if I have an activity that's configured to execute when another activity looks like it's going to be late, right, it's a prediction, that behavior is the same no matter if it's your algorithm or our default algorithm or whatever it is you wanted to choose. But the real beauty of the whole thing is that all the tools you need to perform the analysis, is what you're going to see now, are built directly into Process Director. It's not just a pipeline off to somebody else's ML engine, which you've all seen. So transformation, modeling, training, and prediction are configurable right in the platform. Data can be sourced internally within Process Director and externally via the many connectors and things that you've all grown to know and love. In other words, Process Director data and metadata is directly accessible as inputs for your ML model, helping you create exactly the type of feedback loop, right, built-in feedback loop that improves ML predictions over time. That's what ML is about. Every result makes the next prediction even better. But external data matters too. So IoT data streams, for example, are important. To facilitate those, we provide integration with Microsoft Azure IoT Hub. Microsoft handles the provisioning and the data collection and so on, feeds us the data to our ML model. Of course, you still have to know your process. I want to say there is no, as in business or life, there's just no substitute for deep subject matter expertise. The more you know, the better off you're going to be. The more you know your process, the better are you going to be. But no one person has all of the tools, right? There's no one-man band here. That's why we enable you to configure and layer this stuff in and fit it in where it works, whether you have a team of data scientists or you just have a couple of clever analysts who know something about applying ML models. we're going to show you all this stuff now so that you don't have to take my word for it. I thank you for your attention so far and for your patience with me as I kind of do my technology here. And let's see what happens.
Good, can you hear me okay? Good. Let me switch this. Hi everybody, I'm Joby. So Scott's gonna help me walk through this. What we're gonna do is we're gonna show you some of the application of this inside of the product. So first thing I'm going to do is just kind of give just a context. So Process Director is a BPM product, and as a BPM product, like many others, it's got different layers. Some of the layers are things like business values that we had talked about in the past. The business values play an important role because they allow that layer of connectivity to external data sources. That becomes important when we're talking about machine learning. So when we're talking about ML and then incorporating that into the system, you'll see why that becomes important. I'm actually going to jump right into it as an implementer, as somebody that would actually be building a learner object. So in this particular model, what I've got is a data set, and the data set that I have is a list of information of employees and attrition rates. So everything about their title, everything about the employee and when they've left. And that's information that then we've trained on. In this case, it's an external data set, but we're going to drill down a little bit into what that actually looks like. So first thing what I'm doing here is I'm looking at a learner object. So I've created a learner object here called employee at risk. And ultimately the result of this, very much like a business rule, it's going to return is the employee at risk and what's the probability, or at risk of attrition, at risk of leaving. And you'll see how this would be used inside of the process in a moment. I'm going to point to a data set. So in this case, I'm actually pointing to a data set directly to an external database. But this is where I might be pointing to an IoT data stream. I might be also pulling data from the system itself. So that becomes very important when you're collecting a lot of data within the system, and then you're turning around and you're using that to help make decisions. So in this case, I'm actually pointing to an external data set.
And of course, that's the system's generating a lot of metadata while it's running. So the time to completion and delays and the handoffs and these things, feed all of that back in to the extent you need to, or it's relevant very easily using this technique. You don't have to ship it back off to your AI platform and somehow integrate it and get it back.
And then as part of the data set, one of the things that's important is, especially in machine learning, is a large, clean data set. So in this particular case, it's a relatively small sampling, but it's already been cleaned. Lots of different ways for that to occur. I'm not going to go into that side. So there's a lot of different products and technology that can help you bring that down to essentially a manageable data set. So we do provide the ability to do kind of very basic types of data transformations where you may want to change rows, you may want to change values, you may want to eliminate things, you may want to take maxes or min. So there's a lot of just kind of fundamental data transformation capabilities, all with the goal of giving you, again, a clean data set that you're able to make the decisions on. So in this particular case, this is the data set. I'm just taking a quick view at this particular data set here. This is where I would test my transformations to make sure the transformations are actually working. So for example, if I wanted to change gender from male and female to a 1 and a 0, that would be an example of something I would do there. I'm going to get into the kind of more the meat of it now. So when I get into the training side, so this is now where I'm actually starting to train the system. I'm starting to configure the system to say, what is it I'm actually going to configure? What do I want this to do? So in this particular case, I actually want to predict a particular result. I want to predict, is this employee, and we'll see what that means in a moment when I say this employee, but is an employee likely to leave? I'm going to also pick an algorithm. We're going to talk a little bit about that as well. And then down below, I have a series of input features. That's my data set. So that's presenting me with the data that's available to this particular learner object that I want to make a decision on. What I can do from here is I'm actually going to start with, I'm going to do something simple. I'm going to take away some of these. I'm going to actually start with something simple. And I'm going to say, I would like to predict, for example, I may want to use just a single input feature. So in this case, I'm selecting travel. So does the employee travel a lot, frequently, rarely? What I can do with that then is train on that. It's going to come back and it's going to give me a confidence level. It's just telling me based on my algorithm that I've chose, based on the validation type that I'm using, what the confidence level is. I can start picking other types as well. So I might actually pick travel and title. I might pick a mix. I can have any number of input features. So as I pick these input features, I can train against that. It's, again, coming back with different levels of confidence. So you'll see in this case, using 2 input features, I have a higher degree of confidence. I want a high degree of confidence, or at least as high as I can get, because this is what's going to be used to predict the result of ultimately somebody making the decision, is somebody likely to leave.
It depends on your data, though.
Yeah.
So if your data is very predictive, then this confidence, which those of you who know ML, is variance explained, right? So this confidence is only going to ever be as high as your data is actually predictive, right? So if you have a data set that only predicts about 4% of the time whether somebody's going to leave, that's the best you're really going to do with the algorithm, right? Because that's what there is.
And again, what this is geared to make it easier for somebody to be able to choose a type of, be able to identify the types of input features that are available, be able to get an idea of what that data looks like, even give them some suggestions as far as be able to run through the different algorithms, run through all of the different input features. So this is configured only to go to a single level deep. Otherwise, this on a large data set, this could take hours and hours to actually come back with suggestions, but it'll come back with a couple here in a moment. But it's giving the business analyst or the data scientist information about the data set and what types of things they may want to use as far as the algorithms and the input features, which is ultimately what you're actually making the choice on. So actually, let me go over here. When we're looking at the data, what's important is also giving the user, the person that's configuring this, the ability to look at that information and be able to understand what the data set looks like. So for example, here, I can take a look at things like travel or a title. I'm looking at the data within the data set, and this gives me an idea of things like the data density. It gives me an idea of the distribution. It gives me an idea of, is this an input feature I might want to use? So this is, again, different ways to be able to visualize that data and then be able to overlay that. What, for example, my attrition rates would be for particular titles, or maybe if I were to look at this based on gender or based on how much they're traveling. This is not what I'm not showing predictive capabilities here. I'm just showing basic charting capabilities, but again, geared towards being able to give you more information about the data so that you can more accurately configure the input features that you want to use. In this particular case, what I'm going to do is I'm going to pick some input features here that I know were performing well. I'm going to go ahead and say marital status, title, and travel. Those are going to be the ones that I actually want to use as my input features. I'm going to go ahead and train on that just to make sure that it actually is giving me a reasonable confidence level. I'm going to publish that. The publishing is something that occurs automatic. So you're going to set up the publishing to occur on a frequency based on an event, but that's something that's ongoing, and that's part of the learning process. So it's constantly evaluating data so that it can make better decisions. What I'm going to do now is show an example of how that learner object is actually used. So in this particular case, I've got just a very simple form that we're going to look at. In this very simple form, it's setting some data. So for example, there's a field on there called attrition risk. And very simply, it's actually just configured to use one of the learner objects just to say, is the employee at risk? Now, it's also using things around likelihood, the probability. So it's using actually a couple of different learner objects, and it's using a couple of different algorithms. And I did that just to also be able to show that, that even using different algorithms with the identical input features, the identical data can still produce slightly different results.
After he shows you this, let's go back to that because I want to talk a little about the encapsulation that represents, sort of compare with business values and other things, business rules. Okay.
So on here, example, I have a form, I'm filling out some information. This might be an example of a performance review. I fill in the information on here. As I'm filling this information out, I'm picking things like title, I'm picking the marital status and how much they're actually traveling. What you're going to notice is these two fields right here are actually being set automatically. This employee attrition risk and the attrition risk radio button are being set based off of those learner objects. So as I start changing my data, what you're going to see is my risk of the employee leaving is going to either go up or down. So I'm going to say that this person travels frequently. I'm going to say that they're a sales executive. And in this particular case, it's telling me here that it's a high risk of them leaving. Where this becomes important is not just in something that I might display to somebody on a form, but this is going to become important when we start tying it to process, and we start controlling how a process is actually running, or what activities are actually needed. But you'll see on here, just as I change things, it's just evaluating that algorithm, and then it's making the decision to say, what is the likelihood ultimately of somebody leaving, based on whatever attributes I wanted to be able to collect based on history.
Based on history,
Yeah, based on history, which is really the key piece. This is an example, again, where I'm just showing the data. Where it becomes really important, where it becomes really useful, is when you start looking at it and you start tying it to process. When I start tying it to behaviors or how I want a process to run. So I'm looking at a performance review timeline. So this is a workflow process. This is going over a process timeline that we've talked about in the past. I'm not going to go into much detail on this. But on this particular one, I've got a series of activities for retention review. So that's a series of activities that might run all the time, but in reality, I only want that to run if some condition is met. I may want that only to run if the likelihood of the employee leaving is over 40%, or if the algorithm is simply just returning, there is a likelihood of them leaving. So in this case, I'm going to configure a condition, and this is really where the strength is in being able to use a very complex learner object as simply as I would a business value or a condition within the system. So in this case, I've picked a learner object called employee at risk. It's returning, in this case, just a very simple yes or no, it's true or not true, and that's going to determine whether that series of activities is actually needed. So it's going to control the path of the process based on the result of that, and it'll be evaluated every time.
Now, of course, every day in a company, this data set gets larger, people come and go, and we learn more about them. So over time, the model itself gets more and more accurate.
So in this particular case, again, I'm evaluating, that learner object is returning information, a yes, no, it's returning back a percentage, it's returning back a value. But a learner object can also return information about duration. So this ties a little bit more into process timeline again. And what I mean by durations is when I go into a running instance, so I'm just going to go into a running instance here. So I'm now looking at a running process instance. This running process instance is showing me that where we are in a process, very simple process, and in this case it's just showing me who's assigned a particular task, where we are, it's showing me who's done, it's giving me some visibility into when this task was assigned to them, when it's due, where we are right now in time, and also when it's likely to be done. And I want to focus on that. That predictive capability is something that's been in Process Director for a long time, but historically that's used the user's past performance in making that prediction, which is a good indicator, but it's not a great indicator because, for example, I was just speaking with a prospect the other day, and one of the key pieces for them was they deal with a lot of vendors. Vendors send in information about products that they want to put on their shelves. That goes to buyers, and it goes through a process internally, and they need to be able to more accurately predict when is the buyer and their group going to be done processing a vendor's request. And if you just used the buyer's past activities or past performance to make that decision, you might come up with something to say that particular request might take on average 2 weeks for that particular buyer or that particular group of users. But in reality, if there's 300 SKUs that were submitted by the vendor, it really is going to take a month. But if there were 5 SKUs that were submitted by the vendor, it really only takes them 4 hours. So being able to configure a learner object now to say what input features are important that I should use in the calculation of or the prediction of that duration is done very similar to the same way that I would use a learner object to predict the result of something. Is somebody likely to leave, or what's the percentage chance? So that same mechanism for calculating that algorithm can be used for the durations as well, which makes now the process timeline much more accurate. So I'm going to jump back over to the learner object, and you wanted to talk about...
Yeah, or there was fine too, but yeah, anywhere that we're just pulling down the menu for the... Just want to show just the encapsulation. So just like you just were, but hold on to the menu for a minute because I want to show...
Wait, which one?
The condition.
Oh, so let me go back into a condition. So doing a condition, again, a condition could be done on anything. It could be done on a timeline, it could be done on activity, it could be done on what fields are required on a form, or what data should show up on a chart. But I'm going to go into this one again. I got rid of that.
Yeah.
But let me go back into here. So this is where I'm defining a condition to say when should this activity run. So very, very simple condition. I could use business rules. I might actually have rules that are static, and the rules might be things that just say if they travel frequently, then there's probably a likelihood they're going to leave. But really what you're doing is you're making a decision there based on instinct or tribal knowledge. You're not really making that decision based on the past data, whereas the learner object allows you to be able to do that using the past information to make that decision. And you, of course, have to pick the input features correctly. That's part of the challenge. That's really where the work is in this, is identifying, making sure you have a clean data set, a lot of data, and identifying the appropriate input features.
So you know, one of the takeaways of this is that the learner objects inside Process Director that, you know, do all this fancy stuff, and Joby showed you how to configure it and all that. At the end of the day, they just act like another piece of data in the data pipeline that sort of runs through Process Director, right? So if you have external values represented as business values through data virtualization layer, if you have case properties or form fields, any information that you want to use to inform the way your process goes, the routing, the assignments, whatever, to inform the way your forms act, to inform really every behavior, every possible behavior of the system, those things kind of all work the same way at the end. If you're the implementer, there's really only one paradigm here for you to learn, and it's kind of how to grab these pieces of data from the data pipeline and use them where you need them. And if you are not the person who configures the business value, that's somebody else, great, but you know how to use it, right? That's what's important. You're the implementer. You don't need to be an expert in that. If you don't know how to configure the ML stuff, somebody else does, great. They can do that. There's a nice separation of roles. You can use it, or anybody can use it in the system. So you almost think of it as sort of a publish, subscribe kind of model or something like that. It's not really that, but something similar to that. I think that's really critical for the ability that we've had in the past few years to introduce things like milestones and the business values and all of those things, because everything is really just, you know, another thing flowing through the pipeline, through the data pipeline. So, anything else you want to touch on? Because I think it's about Q&A time.
Yep, nope, I think that was probably it. And I think that did hit on an important point, is that distribution or that separation of responsibility. So the person that's actually defining a learner object may not be the same as the consumer or the person that's using it, but the same is true for business rules. So inside of an organization, you're going to have folks that are actually configuring business rules, because they're the subject matter experts. They know how something should behave, or when something's needed, or when should additional credit checks be done. So that can be a different set of users that's defining those business rules than is defining the process or some other parts of the application. Very similar to business value and to the learner objects. So it can be the same person, can be totally different groups, but I still consume or I use it in the same way.
Yeah, we just meet you wherever you are. So if you have a whole team of people doing this, great, they can do that. If you have, you know, your one IT person who's just doing everything and configuring everything, you know, they can do that too. And
then the only other last piece on here is on the machine learning. So the algorithms, we've plugged in a series of different machine learning algorithms. They're out there. These aren't ours that we've written. The advantage there is that we've picked some that give us the best in dealing with the different types of data, both numerical and categorical data. So the ones that actually give users enough options to be able to choose things so that they're getting back the results that they would expect. And there's other parts to the kind of this entire component. There's sentiment analysis. There's other pieces. This happens to be, for me, the most exciting, because being able to leverage data that's out there, and there's just a lot of data now. Customers have a lot of data, not just in our system, but in other systems. Being able to leverage that now and be able to help them not just run a report on it, but actually learn from it and change process behavior from it. For me, that's been the most exciting.
Yeah, the ability, right, yeah, absolutely, you know, critical is the ability to say, well, what data matters, right, in these calculations? We help you with that. We help you decide that. Or, you know, if you know how to do this on your own, you know, you can sort of do it on your own. But this isn't just us. In machine learning, as Nathaniel was saying earlier, it's all about the data. It's all about the volume of data and the accuracy of your data and the predictiveness of your data. none of those things may be under your control, but that's what it's about. And the more you have of each of those things, the better off, the smarter your automation is going to appear. So I think it's Q&A time. Thank you for listening to us. I always start with Bruce.
Yeah.
So do you have that intriguing button called Suggest
Yeah.
Input Features and Algorithms? What is that?
So you configure it. So in reality, when you're actually doing the training, it's not something that occurs. It's slow because you're dealing with a lot of data. For demo purposes, we got a relatively small data set of a few thousand records just to kind of make it a little bit more manageable. What the Suggest actually does is goes through all of the different algorithms and goes through all of the different input features. So even though I've limited it only to go one level deep, because it actually can test not just one layer of input features, but variables. So these two and those two and these three together. So it can take a long time, but
If you had 2 hours for your demo, you'd be hitting that button.
I'd be spending a lot of time there. So
This is just running on this little CPU
yeah, and
here.
the reality on these is it also is something that you're going to run and then it's going to come back and it's going to tell you later. These are the suggestions. What the suggestions are doing are simply just running through all the variations, all the permutations of those input features and algorithms, and then just coming back and telling you, based on that, this is this set of things have the highest confidence level. That doesn't mean that's exactly the data that you want to use, but it's just telling you that's the highest confidence level. Those it's a place,
Exactly,
and
right.
that's the key. So I don't want to turn that into like that's gospel the moment that you see those results, but it gives you a place to start. As does the visualization of the data. Just being able to know data density, just be able to know, am I dealing with a data set that has 1,000 different distinct values versus 5, being able to see where it's weighted. These are all tools to give you that starting point to be able to help you in picking that. Now, in some cases, it's going to be easier than others, because if I know my data, it's going to be relatively straightforward for me to have an idea. And sometimes it's common sense, like the example I was given a moment ago when they're saying, I need to know how long it's going to take my buyers to go through this process. Well, a good starting point for them, they don't need this. They say, I know if there's a lot of SKUs that are being submitted by the vendor, that takes a lot longer for them than if it's a few SKUs. Now, there's probably other things they're not aware of that can start flushing out.
Anybody else? Lloyd.
So a lot of attention was paid to the machine learning aspects for employee detection and intervention, right, with respect to
Sure.
steering them away from leaving, right? Did you have the same kind of firepower thrown towards the effectiveness of the remediation actions?
Well,
Do you have a kind of set list that you work with?
So I think what we're showing is that if you every time you want to make if you want to make a prediction and you have the data available and you're able to find an algorithm, which is not easy necessarily, able to find an algorithm and the input data set that matter, right, for you, you can always do that prediction, right? So this thing we showed you just now with employee attrition, it was just a sample solution. But yeah, you could certainly apply that kind of thing. In fact, to be honest, and I know this is true because I worked with the data before, between the last time I saw this data and now it's a lot more predictive, so I think somebody...
I had to do a little transformation to strip out some data, and because it was, some of the data wasn't clean.
It turns out it's actually hard to predict when employees are going to attrit.
Yeah, especially with a small data set. So again, this was for demo purposes, a very small data set.
Well, I'll give you an example. For law schools, they look at your LSAT and your undergraduate GPA to make admissions decisions. Those two numbers together, which dictate your whole likelihood of getting into the school you want to get into, actually only account for about 15% of the variance in actual success, right, in actual outcomes in law schools. But it's the best they can do, right? 15%, that's the best they can do. And so they use it religiously. Maybe over-rely on it a bit. Oh, yeah, I'm sorry.
Two questions. One is related to
It's my glasses. My camera.
suggest or train. I wonder if you use like a distributed system behind the same cloud to do parallel rather than do it local.
I can't hear you, I'm sorry.
Sorry, I mentioned about the learning. Instead of doing it locally, doing like in a supercomputer in the cloud, to do in parallel to figure out what would be the best rather than, do you have that?
Yeah, so, well, and we let you offload those things too, but, and we don't suggest you run it on a laptop, but the training itself, you know, is the expensive part, right? The predictions are, you know, single polynomial, like it's O of one time, it's nothing. So the training you can run like overnight when your system's not busy. You know, it depends on the frequency you need to, you know, update it, or you could absolutely farm it out so that it's running on, you know, some big memory, big CPU thing, and just, you know, feeds you back the answers. You know.
So the second question has to do with the topic itself, about ethical aspect of make it like democratizing these things. So imagine a data scientist looking at the data and trying to be unbiased versus, okay, here's a screen, click a button, and maybe your racial profiling. I don't know.
Right.
Maybe. So
Yeah.
how?
Well, so that's a fundamental, and we could talk about that often. Maybe I should do another presentation on that if somebody drops out. In general, machine learning has a bias problem. As Nathaniel was explaining earlier, happened with the, whose was it, Microsoft or? Amazon's Nazi bot. So you do have to worry about the way that, because you're taking past, you know, you're taking history and predicting the future based on history, right? So if the history is you always put a certain subgroup in jail, then it's going to predict in the future you're going to do that as well. That is something, it just as a general AI problem, not having anything to do with anybody here, so the general problem in AI is really a huge issue for them and something that they're working on.
So what I meant is that I agree with that, is like when you have data scientists, they go to training, ethical training, all that, but by having a UI like this to someone who has no training, without even knowing, they click a button and do it without going to extra, like a disclaimer, please, you know, this age or something, things you may be discriminating.
Yeah, but
You know, that
I'd make
aspect
the
of it.
same argument about programming.
Joby, Scott, thank you very much.
Thank you. Thank you.